Hello CS412, we are Thanatos. Our group members are John McConnell and Gaurav Bansal. We're two online MCS students from California. Before we get started on our algorithm and implementation, we wanted to discuss how we're trying to solve a real problem. Web Data View aims to give users an easy solution to find and extract data from messy websites found all over the internet. The typical modern website is relatively unstructured and is filled with data that is not necessarily of any interest. Think of how many times we've been searching for data or information only to find a brick wall of ads between your data or miles of scrolling between things that you want. This begs for a tool to turn the sparse, useful data that people care about into something a computer can scan and manipulate, as well as even perform data analytics on. The main problem stems from the fact that websites are designed to be aesthetically pleasing, which oftentimes results in the data being unstructured. A data-focused user wants to model a web page in a data-oriented way. We want to offer users a data entity model. This will allow us to solve the general purpose problem and not a domain-specific one. Here are some stories we came up with. Me being a poor college student, it's important to me to find the cheapest flights possible. I only care about the airline, departure and arrival date and time, and price. I also want to merge multiple websites that don't stack results together in order to perform a cost analysis on. Another example relates to my work. Oftentimes I have to go out onto the ocean, and it is important to me that the ocean is calm so I remain safe. I can use past history of wave height and frequency to forecast if a future date will be safe. Another example we looked at related with ingesting text for the purpose of performing NLP. We use Reddit here and determine that we only care about what the post is about, where it was posted, and how old the data is. With this, we can use NLP to derive conclusions about important topics such as the economy.
Thanatos comes in by classifying the data entities which are embedded in the web page and classifying them as either being important or unimportant. And the big idea for a data entity is that it's some entity which comprises a DOM element from each category, right? Title, domain, votes. So I'm going to skip over user input because you'll see it in the demo, and I'll show you a brief overview of our solution. We had a couple of problems, and so we'll get into this one, is the number of DOM elements on a web page is actually quite large, so we need to shrink that down. For us, we use k-means to cluster things which probably belong in the data entity model and things that don't. Afterwards, we have candidate entity generation, because we need to kind of say, hey, we've got all these DOM elements, how can we structure them into things that are actually entities? After that, we have PU learning, because we have positive examples and we have unlabeled examples through candidate entity generation, but we don't have any negative examples. And we kind of loop through this until we have convergence. A couple of insights about what makes these DOM elements part of the data entity model or not. As you can imagine, things that belong to a certain category are visually similar to each other, and so we use visual similarity. I'm not going to go through all these, but you can look at it if you want. And then also, now you have things that belong to a certain category. How do you combine them together? We have the spatial model, right? So things that can be combined together are similar to each other based off their position in the web page. And here we use kind of a geometric representation of that, and we can get into that. And then 1, 2 is, you can see we can kind of also include the variance from the midpoint, right, where these DOM elements lie. So candidate entity generation, I won't go into it, but basically if you do the naive approach, it's exponential, and so you can't do it. You need to do something smarter than that. But I don't have enough time to go into it, so we won't. And then also for Pebble Learning, we talked about that. We have to use positive unlabeled because we don't have negative examples. So some mistakes that this algorithm falls into, the data entity model itself doesn't reflect the real world. There are categories that don't need to exist, DOM elements that don't belong to the category, and that this entity is just missing. So we can see the first one, we have title, domain, comments, title, domain, comments, and this last one has title and domain, but there is no comments, and it breaks the model, and the algorithm cannot handle this
Here
situation.
I'll show you a brief example or a brief demo of our Thanatos solution. So suppose you're on a Reddit web page and you want to grab the votes, the title, and the domains from each Reddit post. You enter it here, you set the fields, and you click Start. You enter some example entities that you want, or else this solution won't really work out too well, won't have anything to learn. And here you can see the result. And you can see how it's grabbed everything from the web page. And you can here notice too that it actually mischaracterized this advertisement. So we click to CSV, we open it up, and now we have our titles, our votes, and our domains for all the parts of the web page that we're looking at. And we can see, JavaScript and converting to a CSV is actually kind of difficult. So you mess up the character encoding. Here we'll show the website behaving in a way in which the algorithm can't handle it. And so we'll do rank, title, comments. We'll tell it to suggest. And we can see it did fairly well, but it missed out on the comments here and here. And we can see it grabbed some stuff here and it actually highlighted this entire giant element right here. And so it has trouble. Okay, that's it, everybody. Thanks.